a 4 variable K-map is given and the ones are there in the K-map, I need to form the groups. So I will briefly go again how the groups are formed. We know we can form we have to form groups of ones, and the group will be of either 2 to the power 0, so 1, 2 square, 2 to the power 1 which is 2, 2 square which is 4, 2 cube which is 8, 2 to the power 4 which is 16. So group of 2, group of 4, group of 8, group of 16, or either by just group of 1. That's what we can form. Now I will form a group and I will write the expression. So let's say I am forming a group, this one, and the expression will be, what we do when we write the expression is we look at here and here and see what is not changing. So a bar b is not changing, so I write that, and on top I can see that c bar is there, it is not changing, but d is changing, so I don't write d, I write c bar. So that is the expression of this whole group. Now this is what the minimized version we get from K-map, a product term we get from K-map. But what actually this one is, how we get it from the K-map is, if we write these two terms by themselves in terms of Boolean algebra, so that will be a bar b, c bar d bar. This is the first one, this one, and the second one will be a bar b, c bar d. Now what we can do here is, if we look at this one in terms of algebra, we can see b bar, a bar b, c bar, we can take that out and it will be d plus d bar. So d plus d bar is basically a 1, so we don't that becomes a 1 and that goes away, and that is exactly what happens when we are forming the groups. So that's why we can directly write the product term from a K-map, and this is the method to write it. Now we have to form few more groups because we have to take all the ones here. So this one I can take a group, I have to make a group of 2, that is better. I should try to make a group as big as possible and also make as less number of groups as possible in total. So one group, bigger group means less term in a product term, and less number of group in total means less number of sum terms, basically, because each group means one sum term. So less number of groups, less sum term. So anyway, I have to take this one, I have to take all the ones basically. So this one I can take either with this one here or with this one here. So I will probably go with this one. So basically these two. And when I look here, what is not changing is b bar is not changing, and here c bar d bar is not changing. So I will write that b bar, c bar, d bar. Then I have to, these two I can take together. So that one, the term will be a bar b bar, a bar b bar here, and here what is not changing is c, so that is c there. So I will erase this part because this is not a part of the expression. So this is our terms, and then this one is, I have already written a bar b bar c, this one, that is this one, and now I have two ones left. Now this one, if I look at this one, this cannot be grouped with anything. There is no adjacent terms. Diagonal is not adjacent, because if we look at the terms, there more than one is changing. Here this one is a bar a b c d, and here this is a bar b c bar d. So they cannot be, actually there nothing can be common, we cannot take anything out. So what we can do, it has to go by itself, so it will be a b c d, that's there. Finally this one is left. I will definitely not take it by itself. I will try to form a bigger group, so I will take this one with this one, so it will be a b bar, and then what is not changing on top is c bar. So that is the expression. So 5 sum terms there, 5 product terms there, and that's the minimized version from this K-map.